How do teachers differentiate instruction for different students in the class? Some students come to us as beginners. They might be struggling with certain mathematical concepts. Others are more advanced for a variety of reasons. How do we differentiate instruction for different students? There are two models: acceleration and enrichment. In acceleration, we provide students who are more able with content from a higher grade level. Conversely, students who are deemed to be struggling are given content from an earlier grade level. In Think Mathematics, we have adopted the enrichment model, where students all stay with the same content. However, those who need more challenge are given more challenge, and those who need more support are given more support. Beginners receive support in a variety of ways: through concrete materials, through collaboration with friends, and a variety of other strategies that Think Mathematics encourage teachers to use. For the more advanced learners, they too have ample opportunities to extend and enrich their learning. For example, the mind workout. The mind workout is for enrichment. In this example, students are given 6 digits, and they are asked to use the digits to form 2-digit numbers, and from there to subtract the numbers. You can imagine how the more advanced learners get challenged from activities like this. They are prompted by the friend in the book. How can we make the answer as big as possible? So while the beginners might make simple subtraction equation, hence solving the problem, the more advanced learners are encouraged to address the enrichment question. How can we make the answer as big as possible? That's an example of differentiating instruction for different learners. The beginners get to do what they can do, and the advanced learners get to be challenged at a different level. Other examples of enrichment activity. In adding two numbers, such as 8 and 6, the beginners might get the sum by counting all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Others might do counting on. 8, 9, 10, 1, 2, 3, 4. 10 and 4, 4 and 10, that's 14. And the more advanced learners might be able to say that, oh, 8 and 6, that's double 7. Because when I move 1 over, I can see that 8 and 6 is double of 7. This is yet another example how beginners obtain the sum by counting methods, and the advanced learners can see multiplicative structures within the addition situation. Another enrichment activity in Think Mathematics is inviting students to use different digits to make a correct multiplication equation. They are asked to make a 2-digit number, perhaps 13, and a 1-digit number, perhaps 2, and from there obtain a product. In this case, 13 times 2, I suppose they can make 26. But in this case, the constraint is not met. They're supposed to use 5 different digits to make a correct equation. That's an enrichment activity. And this allows the beginners to make simple equations. The beginners might make 1 or 2 multiplication equations. That's accessible to them. And the more advanced learners may be able to make quite many. And after a while, they may be able to challenge themselves, perhaps through prompting by the teachers. For example, they might have made 13 times 4, that's equals to 52. And the teachers may prompt them Did you notice that you're using 1, 2, 3, 4, 5 to make your equation? I wonder if you can find another equation that make use of 5 consecutive digits. That's indeed challenging. Or the teachers may say that, oh, your product is even. Do you think you can make a product that is odd? In this activity, beginners are able to access the problem by coming up with 1 or 2 multiplication equation, and the advanced learners can be encouraged to investigate interesting observations that resulted from whatever they have done. That's another example of an enrichment activity.